Alright, so the last time round, okay, I brought in the notebooks for us to actually try to submit things online. Okay, so I think that when it comes to writing things as a product of prime factors, we are quite clear about it. Now let's take a look at practice now 3, textbook page 8. Okay, let me close this. Okay, so in this question, it says that to express 2021 as a product of its prime factors. Okay, so how do we go about doing our prime factors? You all recall? Do prime factorization and we make use of our ladder, right? Okay. Now, what is the first number that 2021 can be divided by? 43. Wow, so fast. Okay. So 2021 can be divided by 43 as well as 47. Okay. If you recall, okay, we try out with the smallest prime number first. We try dividing by 2, then we divide by 3, 5, 7, and so on. Whereas for this case, the smallest prime number that 2021 can be divided by is actually 43. Okay, and then we'll be left with 47. We can divide by 47 again, and then we arrive at 1. Okay, so I hope that you recall this method. You remember this? Okay, so 2021 will be 43 times 47. Okay? Whoever do this question yet, right? Okay. Because you look at me like you already know this. Okay, let's go at part 2. Given that A and B are whole numbers, such that A is less than B. So a very important part of the question is that A is less than B, and A and B are whole numbers. Okay? And a very, very important thing to note is that A times B must be equal to 2021. Okay, question asks us to write down all possible pairs of A, B. Okay, so in this case, A times B to be 2021. One possibility is based on answer in part I. What is another possibility that it can be? 1 times 2021, right? Great. Okay, so we can have 43 times 47, otherwise 1 times 2021. Okay, question also say that A must be less than B. Alright, so A must be numbers on this side over here because we notice that numbers on the left side are smaller than numbers on the right side. It's just a coincidence that I write it that way lah. Okay, so all my possible pairs, okay, the possible pairs because the question asks us to write it in this format, whereby the number A comes first, then the number B, with brackets and a comma in between. So we write it as 43, 47, and 1, 2021. Okay? Any questions? Now, let's look at practice now 4. That's in your textbook, page 9. Okay, alright, practice now 4 on this side, alright? Okay, question says that Imran uses 195 1 centimeter cubes to make a cuboid. Okay, so we have cubes that looks like this, each side 1 centimeter, and then it is all being placed together to make one big cuboid. Do you know what's a cuboid? A rectangle. Then what is a cuboid when it's a rectangle? 3D rectangle. It's a 3D rectangle in some sense lah. Okay. So with this cuboid now, okay, question says there's 195 of 1 centimeter cubes. Each side of the cuboid is longer than 1 cm, so there is a condition to the size of this cuboid. They must be more than 1 cm. Longer than 1 cm in size. Okay, what I'm trying to do over here is to help you visualize what the question wants. It is purely up to you whether you want to draw diagrams like this or not to understand the question. Okay? So the question says want to find the dimensions of the cuboid. Dimensions will mean that we want to know what is the length, the breadth, and the height. Okay. Now, because there is 195 1 centimeter cubes, right? Okay. Each cube is 1 cm inside, 1 cm in dimension, each of the sides. Okay. I want to ask you, alright, the volume of 1 cube, what would this volume be? What's the volume of this 1 cube? 1 cm cube, right? Okay. And if I now have 195 of it, what is the total volume? 195, right? Okay. So that means that my entire cuboid, since it is made up of the small cubes, the volume itself here must be 195 cm cube. Agree? Okay. Now, what is the formula for finding volume of a cuboid? What do you remember from primary school? Length times breadth times height. Wait. Okay. Okay, so 195 must be made up of length times breadth times height, which are the numbers that we want to find. Okay? Now, there's an easy way to go about finding this without having to go through every single combination. Okay? What we can do is to make use of the prime factorization method that we have just learned already. Okay? 195, this number itself, okay, if I break it down into its prime factors, what would I actually get? So, let me put my letter over here. 195. What is the first number that I can divide by? 5, 3, 3, 5, 3. Okay, let's do 3 first. Then I will be getting 65. Then I divide by 5. I'll get 13. And then 13. Okay, sorry, that's 1. Okay, so what this tells me is that 195 can only be comprised of 3 times 5 times 13. And coincidentally, these numbers cannot be further broken down. Okay, and we're looking for length, breadth, and height. Okay, what this means is that my length, breadth, and height, the dimensions of the cuboid, can only be of this combination. Understand what I'm trying to say? Okay, because we agreed that from 1 cube itself, which has a volume of 1 cm cube, I made it up into total of 195 cm cube. 195, when I break it down into its prime factors, okay, I will know that it's 3 times 5 times 13, so the length, breadth, and height must be 3, 5, and 13. It doesn't matter whether in this case, which one is length, which one is breadth, and which one is height, because no matter what for your cuboid, you turn it around, okay, it will change the way you define your length, breadth, and height. Okay. Additionally, in this question, they are asking for the dimensions only as well. Okay. So the dimensions will just be 3 by 5 by 13 cm. You don't have to specify which one is the length, which one is the breadth, or which one is the height. Okay. So therefore, in conclusion, the 3 dots over here that form like a triangle symbolizes. Therefore, you can use that. Okay, that kind of short form. So therefore, dimensions of cuboid are 3 cm by 5 cm by 13 cm. Okay, that will be the answer. Any questions? in this case, for my cuboid, what is the volume going to be? 324, right? Okay. The question in this case gives additional information. It tells you that the perimeter of the top of the cuboid is 18 cm. Okay. What this means is that the top of the cuboid over here, perimeter means the sum of all the sides will have to add up to be 18 cm. Okay. And also the question says that each side of the cuboid is longer than 2 cm. Okay. So with the information from the question all laid out like that already, how do we go about answering the question? Let's employ something similar that we have already done. So earlier on, what we did is that taking that volume of the cuboid, I break it down using my prime factorization method. So let's do the same for this as well. 324, okay, if I break it down into prime factors, what is the first factor that I will divide it by? Sorry, I keep forgetting Kyra or Kira again. Kyra, right? Okay, Kyra, can you tell me 324 divided by what? Divide by 2, okay. So then what do I get? Kyra, what do I get? 324 divided by 2. This calculator. 162. Kyra, can you confirm that? 162, okay. So 162, then we continue, divide by 2 again. 81. Okay, then after that we divide by another 3. What do I get over here? 27, right? Okay, so we break it down like that. Okay, so for this number, right? I noticed that when I was looking at your SLS work, okay, when you're asked to actually do prime factorization and all that, you only do this. Okay, this is not an answer itself, this is only a working. Okay, you need to translate this into proper information to tell me that 324 equals to 2 squared times 3 to the power 4 into its index form. Okay, usually we leave it in index form, okay, so that it's neater since we already know how to write it neatly rather than writing it out all in this multiplication. Okay, so now that we have it in this, the problem here is that this number is not as neat as our 195. For 195, I can distinctly be able to see 3 different numbers that can form my length, breadth, and height. Okay? But the problem over here is that I have 2 squared times 3 to the power 4. Okay? But I need to identify 3 different numbers for my length, breadth, and height. Okay? So our next question is, what are these 3 numbers going to be? Understand? Okay. So for these 3 numbers, they are bounded by 2 different conditions. One of the conditions is that it must be longer than 2 cm. Okay. The other condition is that the perimeter must be 18 cm. Okay. So our perimeter, let's call it being formed by our length and breadth, which we call A and B. Okay. If this side is A, this side is B, what's the length of this side here? A, right? And this side will be B, right? Okay. So our perimeter is actually made up of 2A and 2B, right? Agree? Which is also the same as 2 times of A plus B. Agree? Because A plus B first, then times 2. Okay, that's why I have the brackets over the A plus B. Okay, so 2 times A plus B must be equals to 18. Okay? Okay, so if I want to find 1 set of A plus B, 2 sets of A plus B gives us 18. 1 set must be equals to 9. 18 divided by 2. Okay? So what this tells me is that my length and breadth must add up to be 9. You agree? Yeah. At this point, anybody confused? So if I let this be A plus MB, okay, A plus B must be 9. Anyone confused so far? Not following? What are you able to get ready, Hera? You confused? Oh, I saw your hand raised up. Yeah? So that's our first condition about the parameter. Next thing that we know is that each of it must be more than 2 cm. Okay? So I will now do a little bit of trial and error to figure out what kind of numbers are suitable. Okay? My numbers over here must match this 2 square times 3 to the power of 4. Eventually must have 2 2s and 4 3s. Okay? So because our 2 square is 2 times 2, 3 to the power of 4 is 3 times 3 times 3. Okay? So I can have this number to be maybe 2 times 3, or I can have this number to be 2 times 2 times 3 also can. So long as in totality, okay, I must see that I am making it out of 2 times 2 and 3 times 3 times 3 times 3. Okay? So in total, there must be 2 2s and 4 3s. Alright? Now, let's figure out this A plus B equals to 9 first. What kind of numbers do you think can be placed here such that the sum will be 9? Yes. 6 plus 3. Okay? So, do we agree? 6 plus 3 gives us 9, right? Okay, so let's look at whether is it feasible. If I have 6 over here and 3, is it possible to have 2 numbers over here multiply each other to give 6? Yes, right? I can have 2 times 3, right? So 2 times 3 gives me 6. So I used up 1 2 over here, used up 2 3s already. Okay? I'm just doing it in a very rough manner. Okay? So now this number over here, what can it actually be? It must be 18y. Okay, because 2 times 3 times 3. Very good. Right? Because you only left with 1 2 and 2 3s. So 2 times 3 times 3, that will give us 18. And then overall, I see that all my numbers are more than 2. So therefore, I have my dimension of the cuboid to be 6 times 3 times 18. Okay? Are there any other combinations? 1 4. 5 and 4, okay? So Xavier proposed 5 and 4. You're Xavier, right? Yeah. Okay? 5 and 4. 5 plus 4, yes, it gives us 9. Let's put it down. Okay? 5 and 4. But my 5 must come out from this 2 square times 3 to the power of 4. Is it possible for me to have a 5? No, right? Because 2 times 3 or 3 times whatever, 2 times whatever, I will never be able to get 5. Okay? So therefore, 5 times 4 is not a possible combination. Okay? Although 5 plus 4 does give me 9. Right? Any questions? Okay? So you will notice that if I go and find every other combination, let's say if I want other than 6, 3 and 5, 4, maybe I want 1, 8. Okay? 1 and 8 itself, it doesn't allow me, okay, to actually have 1, 8 because of this 2 square times 3 to the power of 4. Okay? So that's why our answer in this case will be 6 times 3 times 18, and the height of the cuboid must actually be 18 because 6 and 3 forms the parameter of the top of the cuboid already. Okay? This thing is what we call the height. Okay? And that height must actually be 18. So therefore, height equals to 18 cm. Okay? Any questions? Why must have what?
Why is the height 18?
Why is the height 18? Otherwise, could you tell me what are you thinking of as answer? 6 or 3, is it? You already confused. Don't know how to get it.
The top is
Okay? Because, right, you see, the question says the parameter of the top is already 18. And our 18 is being formed by this idea over here, A plus B equals to 9. So down here is A, down here is B already. And those are what we call length and breadth. Height is over here, right? Okay? So height doesn't count towards our parameter. That's why, since we know that this is 18 already, our height must be the one that's 18. Okay? Any other questions? You all good? Is it you all find this too fast or too slow? over here. Activity 9. There is this thing. I want you to go home and try it if you have tried yourself. And then homework. Okay, let me write down the homework on the whiteboard. This is our first homework. Question 1, 8, 9, 10. Okay, would like you to submit this homework by tomorrow. Is it possible, right? Possible, huh? Okay, so I have it next Monday then. Okay, next Monday. Is that okay? No. Okay, so I expect all the homework will be submitted on time next Monday. For this, do where? For homework? Do on foolscap paper, not notebook. Okay, foolscap paper. Okay, are we done copying this already? Could I clean up the whiteboard? Not yet, is it? Done already, huh? Okay, I clean up the whiteboard, Okay, so just a reminder about homework. Okay, how it should look like. On your Google Classroom class expectations, on your foolscap paper. Okay, how many of you are using foolscap paper? Okay, if you are using foolscap paper, then good lah, because they will have clearly where you write your name, class, index number, and all that. Just follow that format. Otherwise, okay, please, I want you to write very clearly the exercise number that you're doing. Okay, in this case, exercise 1A. Write down your name, index number, and your class. Okay, question 1A. I don't know whether they are parts or not. If there's a new part or new question, please leave one line before you begin the next one. Okay, don't write in columns. No, now space in the first page already. Go to second page. Okay. So on the first collection of homework on Monday itself, I will then look at the quality of your homework. Okay? Then it's submitted. If you don't know how to do, no need to worry. Okay? The last thing I want you to do is to copy your friend's homework answer. No point copying. You copy for what? Are you here to become a photocopier? No, right? Okay, we are here to become math students. Okay, to learn how to problem solve. Okay, so please make sure that do your homework on your own. Okay, don't know how to do, you ask it in class before I collect. Okay, I will definitely ask you whether there are any questions or not. Okay, before I collect the homework. Alright? So that's for Monday. Now going back to our home-based learning assignment. Okay. I just like to check. Okay, are we clear from the first section? Okay, let me just run it through. Okay, for first section over here, are we clear about our squares and square root, cube and cube root? Yes, okay, they are inverse of each other. Okay, that means they are opposite. Just like our plus and minus are opposite of each other, times and divide are opposite of each other. Okay? Then, this one is just for me to understand. I think most of you are able to articulate the idea, alright? That not all numbers can be perfectly square root or perfectly cube root. In fact, there's a name, okay, for such numbers. Okay, if a number, okay, can be perfectly square root or perfectly cube root, in the sense that when I press square root, okay, of a certain number, it comes out to a whole number. Okay, which is the answer for this. There are numbers that produces a whole number, okay, when its root square root is taken or when its cube root are taken. Can you give me an example of a perfect square? What is an example of a perfect square? 4. What else? 9. 25. 16. Okay. Right, I think you get the idea. What about perfect cubes? 125, 18, 18 you sure? 81, 81 is 18. No, but 81 is 3 by 3 by 3 by 3. 81 is not. 27. 216. Anything else? 8. 8 or 8. Okay, 64. Alright. Okay, I think we get an idea. Okay, I understand you all get it already, yeah? Now, between these two numbers, I noticed that there isn't much overlap between these two. Can you give me the smallest number that can be both a perfect square and perfect cube? 1. Okay, great. Alright, so 1 itself can both be a perfect square and also a perfect cube. Okay? Now, next, are we clear about how to press calculator? Because I do notice some of you don't give me the right answer. Is it clarified already? And are you able to do this already? Yeah? Then I shall not go through this. Okay, I want us to take a look at this practice now 9. Okay, I'm not sure what kind of quality of writing you have in your notes. So take out your notes that I gave you all the other day. Okay, I want us to take a look at this question. Because in secondary school, we got to be very particular about the way we present our answers. Okay, so I want us to take a look at the notes that you have written down in your worksheet. Okay, I see some of you don't have the worksheet, right? If you don't have it, I just want you to turn to your textbook, okay, and check your notebook as well to take notes. This is practice now 9, that's on page 40. Okay, so I believe you are all able to get an answer, right? What's the answer to this question? 1, 1. Click on where's my answer. Wait, I can't find it. 125.7 cm. Okay, yeah. Okay, now how to present? Okay, question says area of the square posted 987. I think we all know that in order to find the length of the square, okay, I need you to actually write down length of the square, okay, is equals to square root 987. This is proper presentation, okay. I will expect this in your homework and everything you submit, okay. Write down length of square equals to square root 987. It will no longer be acceptable if you don't give me this sentence and just calculate for me. Okay? Clear presentation is expected when it comes to secondary school. Alright? Length of square equals to square root 987, which upon calculating in your calculator, okay, what do we have? What do we get? Xavier, I notice you're not writing anything. What do we get as answer? Okay, 31.416 euros. Alright, so 31.416. Okay, but this is not all the numbers you see in the calculator, right? There's more, isn't it? Okay, at this point, before we go into chapter 3, I want you to leave your answers up to 3 decimal places. Okay, and I don't need you to round it off. You just have to truncate. What truncate means that you chop off the numbers after 3 decimal places. Okay? So truncate means chopping off, okay, the remaining numbers. No need to round off. Okay? For now, we will have this practice. Okay? Questions? Alright? The reason for this, okay, is because of accuracy issues. We'll talk more about this when we reach chapter 3. Okay, so the question wants us to find the parameter. So the parameter, since it is a square, I can take 31.416 times 4. Okay, again, need to indicate for me parameter equals to something. Yes, 4. Okay. And then what you get over here will be 125.664. Okay. Question wants it to be 1 decimal place. So 1 decimal place is over here, the first 6. we need to round down or up? Up. Okay, and that will give us 125.7 cm. So this is rounded to 1 decimal place. We put brackets 1 pp. Yes. Do we have to write the exclamation sign? Oh, this sign? Yes. This one, first 1 pp, you can put equal sign. This one is exact pp. Yeah. Okay. Okay, any questions? No? Okay. Then after that, any issues regarding this question? No? 5, 6 are your got a lot of issues, eh? Yeah. Any problems regarding this question? You answer me. Shall I go through this question? Go through, okay. Now this is your practice now 9, question 3. Okay, it says that Nadia has 2020 or 2020 1 centimeter cubes. She makes the largest cube possible using some of the 2020 cubes. How many cubes does she have left over? Okay, so from very small cubes, right? It is being made to form one very big cube. Okay, now we know that for the small cube, because they are all 1 cm in size for each side, the volume is actually 1 cm cube, which is what we agreed upon earlier on already. Okay, because we have 2020 and we want to make the largest possible, let's look at what if, okay, we use all the 2020. If I use all the 2020, that means my volume over here must be 2020. Okay? Okay? And because this is a cube whereby all sides are equal in length, that means that my volume, okay, if I use the formula length times breadth times height, all the numbers over here are going to be equal. Okay? Okay? But since all the numbers are equal, it is as good as writing it as one single number to the power of 3. Agree? If I want to find out what is this number, what I will do is to take cube root. Right? Okay? But then the thing is that if I take the cube root of 2020, do I get a nice number? No. What do I get? 12.6. Okay? 12.641, right? If I truncate to 3 decimal place. Agree? Let me just quickly check. In case I'm right. Yeah. Okay? So now, because we don't see it as a very neat number, a whole number, in fact, what does this tell us? It tells us that 2020 is not a perfect cube, and it tells us also that it is not possible to use all the 2020 cubes to form this one big cube. Okay? So that means I can only be using lesser than 2020. Okay? And yet, I must be able to form a perfect cube number because all the sides must be whole numbers and must be equal in length, right? Okay? So what does this mean? With the 12.641, can I choose 13 cm as my length of side? Why? Why if I use 13? Okay? If I use 13, then 13 times 13 times 13 will be 2197, which is more than 2020. Right? So I shouldn't be rounding up. Okay? I'll look for the next smallest whole number that I can get out of this, which is going to be 12. Right? Okay? So if I use 12 itself, 12 cube, what do I get? Okay, I will get a perfect cube number that is 1728. Right? So length of each side equals to 12 cm. Okay, and then number of 1 cm cubes. Okay, number 1 cm cubes that we will be using will actually be 12 times 12 times 12. Okay, which is going to be 1728. Alright? I should be using 12 because I want the largest possible cube to be built up. Okay? Because I cannot go 13, the next number I should choose is 12 already. If I use anything lesser than that, then I will not be getting the largest possible cube. Okay? So, but the question wants you to find how many cubes does she have left over. Right? Because there are 2020 cubes, so number of leftover cubes will be 2020 minus 1728. So that will leave us with 292. Okay. Questions? Okay, so this will be an expected presentation, yeah, of working. Okay. Now, this square root 784, right? I saw some of your answers. Okay, some of you are getting the idea, some of you are not. Okay. So could I just trouble you to look at what you have written down as your own working and check with what I am going to present. In fact, I already presented the final answer when you submit after you have submitted the answer. Okay. So 784, right? You will actually do your prime factorization, your ladder method. Okay. Go and figure out what are the numbers we will get. My work. Okay. 2 and then 3, 9, 2, 1, 9, 6, 9, 8. Okay, so 784 can be written as such. We will write it as 784 equals to 2 to the power of 4 times 7 squared. In order to find square root of 784, okay, if you have watched the video, we are looking at square root of 784 equals to square root of 2 to the power of 4 times 7 squared. Okay, so 2 to the power of 4 times 7 squared, when you want to square root it, okay, we are trying to divide the numbers equally into two groups if you watch the video itself. Okay, so 2 to the power of 4, that means each group I can have 2 2's. And the 7, since I have 7 squared, that means each set I get 1 7. Okay? But if you're quick enough, you will notice that when I take square root, what am I trying to do to the power over here? I'm dividing by 2. Very good. So actually, do you need to write down this step of working? You wouldn't really need to, because immediately from here, you will be able to tell that I will have 2 squared times 7. Okay? So if you're quick enough to know this step already, and you know that taking square root means to take the powers to divide by 2, you can immediately skip through these 2 lines and then tell me that square root 784 is equals to 2 squared times 7. Okay? which is then going to give me the answer 28. Okay, so then that will be the answer. Alright, questions? Are you following what I'm trying to say today? Okay, because you're giving me a lot of blank faces. I'm not really sure whether you understand what I'm saying or not. Or am I trying to repeat too much? And because Xavier is like looking at me very boredly, it's like waiting time for pass. Xavier, are you okay? Are you okay? You're like not copying anything. One whole lesson. You copy already. Okay. Alright, so with that idea, so comes to question 2, right, of practice now 5. Okay, without using a calculator to solve this, question actually already did the prime factorization for you. So I saw that in some of your working, right, you gave me the prime factorization, which was very unnecessary and a little bit of waste of time. Okay, yes. Okay, so 7056, question already told you this is the case. And just now we concluded that taking square root means our power will divide by 2. So that means square root 7056 is equals to 1. Let me just call on it. Hansheng, sorry, forgot, yes. 2 squared times 3 times 7. Okay, great. So just divide all the powers by 2 and follow accordingly. Okay, then 2 squared times 3 times 7. While the question says without using calculator, what they expected to see in this set of working, if you really find it difficult to calculate 2 squared times 3 times 7, you can just press the calculator. 2 squared is 4, 4 times 3 is 12, 12 times 7 is 84. Okay, if you're not that good in mental calculation, you can use your calculator lah. Or okay, any questions? So with that same idea, okay, it applies to your cube and cube root. So 2744 over here likewise, okay, you do your prime factorization and get the answer. Do you need me to go through this question? No? Alright. Okay. Then for this question, I erase nothing else on the whiteboard. Okay. For this question itself, it was really just to get your understanding, that's all. Okay, observe the prime factorization of this number, state the relationship between the powers and the type of numbers they are. What I wanted you to notice is that 784 and 7056, okay, they are what we call perfect squares. And then 2744 and 9261 are what we call perfect cubes. Okay, so this is a perfect square and this is a perfect cube. Now what do we observe about perfect square and perfect cubes regarding its power? For perfect square, what do you notice about the powers? They are all even. And then for perfect cubes, they are all odd. Is it just about being odd? Okay, because we know that if I give you 3 to the power of 5, is this going to give me a perfect cube? No, right? Because if I were to take cube root for this number, am I going to get a whole number? No, right? Okay, so what is even important about perfect cube is that the powers must be what kind of numbers? They must be divisible by 3. Okay, whereas for perfect square, the powers must be divisible by 2, or in fact we call that even numbers. Okay, so I need you to be able to draw that relation between perfect square and the power to be even. Okay, and then for perfect cube, the power must be divisible by 3. Alright? Questions? No. Okay. Then going through this mental estimation thing. square root 1, 2, 3. Okay, what is the number that you want to choose for square root 1, 2, 3? To estimate. Let's go back to this chart over here. What is a good number to choose if I want to square root 1, 2, 3? We choose 1 to 1, right? Because it is a perfect square. Okay? So therefore, square root 1 to 1, I will estimate it to be square root 1 to square root 1 to 3, I will estimate it to be square root 1 to 1. Okay, and then that will give us 11 as our answer. Right? Okay, and then for cube root of 1, 2, 3, what should we choose? 1, 2, 5, right? Yes. Okay, and that will give us 5 as our answer. Okay. This one I shall give it a skip. Alright. If there are no questions, then homework. So since every end of the section we will have homework. Question 1C, 2C, 3C, 4D, 5B, 5C, 9, 6B, 9 and 10. Okay? Sorry? Why can't we do all the questions in your exercise? I only one person. If you got 20 questions in exercise, how am I supposed to mark 33? The same thing. It's very tedious. And it's not about the quantity of what you're doing, okay? It's about the quality itself. Okay, please don't give me all. Okay, I know it is out of goodwill that you want to do all, but I don't have the time to go and mark all your questions, okay, for 33 people. Okay, I will mark until next year to have a finished marking. Okay, so please, this is sufficient already. In fact, I think this is a lot of homework already. Okay, but deadline for this homework only be on Monday as well. Whole weekend do this one due on Monday 10? Okay, great. So everything due next Monday. Okay, could I please have you do it on separate foolscap paper? Okay, separate foolscap paper for each exercise. Yes.
What is the exercise on?
Our page 15 to 16. Okay, this kind of thing I'm sure you have the capacity to take your own book. Okay, come in.